Okay, you're seeing the notes now. We're in the section 24. We're going to do the examples. I certainly want to encourage you to look at the series that we say you should know about. Certainly the geometric, that's been covered since Math 120. We did e to the x this semester. We did sine of the x. We did cosine x. I'm going to say these first four probably should be known and remembered. All right. Now, I'm not going to say there's any hard facts about this, but I would think it's unlikely that students could retain number 5, 6, and 7 for any long period of time. Now, maybe locally you could retain those by the way, but I'm going to say long-term, probably hard to remember those. I will say this though, these are fairly easy to derive if you're willing to do the work, all right? And we actually derived, I believe, 5 and 6. 7, I don't believe we derived 7 yet. That's a generalized binomial, all right, for any value k. All right, so I'm going to start doing the examples. As I do the examples, they may look slightly different than the way you want them done, but the bottom line is the way you want them done, the way I'm going to do them may have different outcomes. I'm sorry, will not have different outcomes, but they may have different roads that lead there. So I'm going to share another share with you. I'm going to go to my whiteboard and just give me a second to do so. And certainly I want to go through each problem separately. And what I'm claiming over here is that we have answer keys for a reason, and there is some work in the answer keys, but the bottom line is we're going to be looking at these and we're going to take it one step at a time. All right. So this one over here, my claim over here, if I were to do this problem over here, I would, the way I would do it is I'd say, oh, gee, I know the series expansion for sine. And what is that? That's x minus x cubed over 3 factorial plus x 5 over 5 factorial minus x7 over 7 factorial. Well, I could go on for days with that, but that's not the point. I don't want to go on for days. And that's going to be plus yada, yada, yada. Series expansion for x is just a simple x. What am I doing? I'm going to divide through now, one term at a time. What do I get? 1 minus x squared over 3 factorial. I'm just dividing term by term, plus x4 over 5 factorial minus x6 over 7 factorial. Well, I'm going to take the one and write a little differently. I'm going to write the bottom down as being, well, it looks like 1 factorial to me. The reason I'm looking at that 1 to 3 to 5 to 7 looks like it's going up by 2, and this would be x to the 0. And that, of course, gives us 1. So let's take a look. And we're going to write a sum down now. And what's the sum going to be? The sum, well, it's going to be a ratio. And the bottom looks like if I start with 0, it looks like 2n plus 1. Let me make sure that makes sense, by the way. You would get, 1, and then 2 plus 1 is 3, 4 plus 1 is, yeah, it looks like it's fine. The top is alternating, so I'm going to say minus 1 to the n. And then I got x to powers. And what's that going to be? It looks like 2n, and this goes off to infinity. I'm going to say this converges for all x except 0. So all real numbers, x can be any real numbers, but x can't be 0. All right. So let me just go back over here, and I'm looking at it, and I want to see if I got the right answer. And I'm looking at this over here, and I made a mistake. Someone says, where's the mistake? I forgot to put the factorial symbol in. And clearly I see that written in this problem over here, but I forgot to write it in. So I'll correct it. And that's a warning to me. Like, I don't want to keep doing that over and over again. I got to be a little more careful as time goes on. Again, what they do is they asked me to graph it out. And certainly we've been graphing for some time now. Maybe I'll go to Sage a little bit later, but right now, let me just look at what it looks like. All right. Now, what am I expecting? I'm expecting to see 2 curves. And the 2 curves I'm expecting to see, they're right over here. One curve I'm expecting to see is sine x over x. The other one I'm expecting to see is that, and again, they said the first 5 terms, right? I'll tell you what the first 5 terms would look like. It would look like this over here. So I'd also graph this out. F of x equals 1 minus x squared over 3 factorial. No, I can't do that by hand, by the way. What I mean by that, I'm not going to graph this polynomial by hand. Let's see, that's 4 terms, right? I get 5 terms. What's the next one going to be? X8 over 9 factorial. So this is also graphed out. It's easy to graph out. But again, if you're struggling with use of technology, I want to encourage you to come by during office hours, and we'll go through that with you. All right. So the black curve is the sine x over x, and this one is that 5 terms that we talked about. All right, let me go back, and I got the graph done. I want to look at this guy over here. And what I'm going to do is they want me to integrate this guy. And I'll be honest with you, that might be a tough integration to do, but they say use a power series to do it. So I'm going to write this down. I know e to the u. And what's that going to be? 1 plus u squared over 2 factorial plus u cubed over 3 factorial, yada, yada, yada. Now I'm going to put e to the x squared down now. And what's that going to be? Let's see, 1 plus x squared plus x4 over 2 factorial plus x6 over 3 factorial, yada, yada, yada. So what I want to do is I want to integrate. All right, so let's write this down. I'm going to integrate this, which is like integrating this. By the way, this is true for all real numbers. So what do you have here? Plus x squared plus x4 over 2 factorial plus x6 over 3 factorial, yada, 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 dx. Well, what do I know? I know there's a constant of integration plus, let's put the antiderivatives down one at a time. X plus x cubed over 3 plus x5, 5 times 2 factorial. No, I'm not going to simplify that. Plus x7, right, over 7 times 3 factorial. And I think I got a feel for it. All right. I'm just going to write this down sort of with my understanding of what things look like to me. I'm going to say probably this would look like 1 factorial. And this over here, probably 0 factorial. You know, 0, 1, 0 factorial, 1 factorial, 2 factorial, 3 factorial. Let's look at the numbers. 3, 5, 7. They're going up by 2. So I would say it looks like 1 over here. And this power is 1 there. Now someone says, why do you go through that trouble to write that down so I can write down what the series looks like in summation notation? And again, we'll check it later. Mistakes do happen. Whoops, another mistake, but I'll correct it before it becomes a real mistake. So let's take a look at this. I'm going to say n equals 0 to infinity. And what do I see? Let's look at the factorials first. 0, 1, 2, 3. So I'm just going to simply say n factorial. Now I see the numbers on the bottom. It's 1, 3, 5, 7. It looks something to do with 2. So I'm going to say 2n plus 1. Let me just see if that works. If I put 0, I get 1, put 2, I get 3, 2, I get 5, 3, I get 7. Looks like it's pretty good. Then I get on top. Let's write this down. X. And what's it going to be? Well, it looks, again, something to do with 2. So I'm going to say 2n, right, minus 1. No, I want to say 2n plus 1 maybe. Oh, yeah, it's the same thing. What am I talking about? I'm done. All right. So let's take a look, see how we did. And I'm going to look over here. I'm going to copy this. And we're trying to teach you how to do homework. And we do that by example. And what's my example over here? I'm looking at my answer, see if I got it right. That's the example we're trying to give you. I got the C, I got the plus sign into 0, 2n plus 1. Yep, everything is looking good. All right. Now make sure I answer the question completely. I gotta look at this thing. Yeah, I get the power series. All right. So that's done. This one, I'll be honest with you. For me, it's a nightmare. But I guess we could go through it. And the reason I say it's a nightmare, yeah, it's a long division problem. And what's a long division problem? And I don't want to write many terms down. They say the first 3 terms. It's a nightmare. It really is. So I'm dividing sine x, which is x minus x cubed over 3 factorial plus x5 over 5 factorial. And here's the nightmare. This just doesn't stop. That's going to be x7 over 7 factorial. And what I mean by that, something doesn't stop. It's really a nightmare. And what am I dividing into? I'm dividing that into x. I realize that right now, let me just see if I can pull this over. You know what I'm going to do? I don't want to have to rewrite that. I'm going to pull this over here. Get my eraser out. Erase this up here. Nobody enjoys doing this, by the way. It's torture. All right, let's take a look at it. Well, what times x gives you x is 1. So what do you get? X minus x cubed. Whoops, that doesn't look like an x, does it? Getting excited. Plus x5. Damn, I'm really making a lot of mistakes here, aren't I? All right, let's subtract. What do you get? X cubed over 3 factorial minus x5 over 5 factorial plus x7 over 7 factorial, yada, yada, yada. Now comes a tough problem. The first one was super simple, but I think they just wanted to write down 3 terms. So let's go to the next one. And we have a key to check too, which is nice to have a key. So let's write this down. It's going to be plus, make sure I didn't make any mistakes here. It looks like x squared over 3 factorial. I'd say, but x squared times x is x cubed over 3 factorial. Well, that wasn't bad. Then what do you get? Minus, ooh, it's going to be a tough one. X5, yeah, wow. And then you get 3 factorial, 3 factorial. Boy, this is going to be tough. Plus x7, 7 factorial, 3 factorial. All right. I got work to do. And I'll put it down what the work is. It's a nightmare. So it's minus x5 over 5 factorial plus x5, 3 factorial, 3 factorial. Well, I got to get a common denominator. And I want to point out, it's not easy, but 5 factorial is really 5 times 4 times 3 factorial. All right. Let's write this down. Kind of looking at it. And this would be 3 factorial. And then I'd get 3 times 2 times 1. So I'm going to say it's 5 times 4 times 3 factorial. Times 3. All right, it's tough though. Let me just erase this up here. It's my little chicken scratch. And I'm going to write this down now. Well, before I do that, I want to point out 5 times 4 is 20. 3 factorial is 6 times 3. That's, and you can see how much work this is. 120 times 3 is 360. Get my eraser out. I'll chicken scratching aside. And let's see, 5 factorial, that's going to be minus 3. And that's going to be plus 3 factorial is 36. So that's going to be 10, right? That's going to be 7x5 over 360. Write that down. I get my eraser out. Erase all this nonsense over here. You see how much work that was. As someone says, you can do the next one? No. I'll tell you why. They just want the first 3 terms down. So I'm going to say that looks pretty easy for me to do. I just got to match that guy. And I'm not going to do anything more work than that. So let me write my little line down. And what's the next thing going to be? Plus 7 x4 over 360. And I'm not going to multiply it this time. I just want to see if I did okay. Because I'll be honest with you, it really brings back nightmares of long division when I was in grade school, how difficult it was. So 1, and this is going to be x squared, and 3 factorial is 6. That's good. And then you get 7 over 360 x4. All right, that's pretty good. All right. So it says, although difficult, that we found this in the past. And if you remember, we were talking about Bernoulli numbers and things like that. At least I think we were. And then they say, use that to do this. And I want to write down what they mean by that. I think I can do it. And I'll put what I mean by that. Limit as x goes to 0. That's an x cubed. And I'm going to use this to write it down now. What is going to be x cubed? The x disappears, by the way, over 3 plus 2x5 over 15. I think you get the idea. Plus 17 x7 over 315 plus 62 x9 over 2835. Well, I still can't do that limit. Limit x goes to 0. I'm going to divide through. And what do you get? 1/3 plus 2x squared over 15 plus 17 x4 over 315. I think you know where this is going now. And that's going to be 62 x6 over 2835. No, I don't want to do any much more than that. Maybe I should put a dot down because it's not right to say that. Man, let me get my little eraser out here. That's a dot. What do I know about that? Every term after the first term has an x in it, and if x is going to 0, all those terms have a limit of 0. So what do I get over there? Real simple, 1/3. All right, let's go to the next page and see how we did. Yeah, we're getting 1/3. All right, like they said. All right, find the Taylor polynomial. These are always kind of annoying for students here, but I want to point out they want the Taylor polynomial centered at 4. So I'm gonna have to write it down. And the way to write this down is knowing what the Taylor polynomial centered at 4. So f of x is going to be f of 4 plus f prime at 4 times x minus 4 plus f double prime at 4 x minus 4 over 2 factorial plus, I could do this all day long, f triple prime evaluated for, I'm sorry, there's a square there, x minus 4 cubed over 3 factorial. All right, now the question is, how could you do that? Well, they give it to you. It's right over here. So I want to point out that, what that n means. It means like, if I put down, f0 at 4, what that means is the n is 0 in the problem. So what'd you get? You would get 1 on top. And what do you get on bottom? Just going through it with you. If you put a 0 there, you get 1. Oh, geez, you just get a simple 1 there. That's not so bad. But, I don't know if I want to do that, nor do I think they want me to do that. What they want me to do is write it down. And I got to be honest with you, it's almost written down. I just got to, put in a summation notation. All right. And I want to point out what this thing is over here is 0. Let me get my eraser out. I'll erase this over here. And I'm going to, maybe clean it up a little tiny, not clean it up, maybe dirty it a little bit. This would be 1. This would be 1 factorial. Right, what will we go over here? X minus 4 to the 0 over 0 factorial. I think I'm ready to write it down. What's it going to be? N equals 0 to infinity. And what do you write it down now? You write down this formula. And it's going to be, let's see what you get. You get minus 1 to the n factorial, 3 to the n plus 1, times x minus 4 to the n. So I'm going to say that's my Taylor series. Now they ask for that radius of convergence. Let me go through that with you. And again, this is one answer. we'll check it later, limit n goes to infinity, absolute value, -1, n plus 1, n plus 1 factorial, 3 to the n plus 1 times n plus 2. Well, that's not so bad. Times x minus 4 to the n plus 1. Let me make sure if I got that right. N plus 1, n plus 1, n plus 1, n plus 1, n plus 2. And then I'm going to divide through by, the other guy was like multiplying by the reciprocal. So I'm going to write that down for you. 3 to the n plus 1, and let's see, 3 to the n plus 1. Then you get -1 to the n factorial, and x minus 4 to the n, absolute value. We want it to be less than 1. So let's see if we can do that. And again, I know it looks nightmarish, but these things are not nightmarish. They really do work out nicely. And what do I get? I get the -1 to the 1. Well, the absolute value of that's with 1, so I'm not going to write that down. And then let me just, I've taken care of this, and that's just simply going to be the absolute value. That's going to be 1. Let's do the factorial now. And what do you get? You get n plus 1. So this thing over here and this thing over here just reduces to n plus 1 now. Okay, let me do the this guy over here. And what do you get over there? Well, you would just get x minus 4 now. All right, I think I did okay. Let me do this now. And what does that give you? It gives you a 3 in the bottom, right? And let me do this now. What does it give you? Well, n plus 1 over n plus 2. Make sure I didn't do anything wrong here. No, I don't think I did it right. All right, let's take a look. Well, I got the absolute value of x. That comes out. And that's going to blow up. That's infinite. So this can be x equals 4 is the only way that could converge, because that has to be 0. So I'm going to say the radius of this thing is 0. Now, by the way, I don't know if I made a mistake, because it just didn't seem like it should work out like that. And I made a mistake somewhere. And you know what? Instead of me looking at an answer, I know I made a mistake. And I'll be honest with you. Let me just see if I made a mistake in the series. I'll copy it. And this is what you want to learn when you're doing homework. You don't get upset and say, gee, I got a wrong answer. Oh, I'll worry about that later. No, you want to go back and see if you can figure out what happened. Let me just go over here. I'm going to paste it in. Blow it up a little bit. And let's see if I got that right. I see it now. And let me go over that. I see that's wrong. So I got to start erasing things. And this is really, a lot of people say, I don't want to do that. I just want to say, I won't make that mistake again, but they don't even know what their mistake is. And I got to be honest with you, you got to go back and you got to make good. You got to make good. Now, of course, if I were on an exam, I'd be a little upset right now. Let's write this down again. All right. And I got to be really careful. And I think I know the mistake now. I forgot to write something down. And that's a problem. Let's go through this again. N equals 0 to infinity. I'm going to write this over here. I'll be more careful this time. This will be f parentheses n for x minus 4 to the n over n factorial. And I'll be more careful, right? I wasn't careful last time. That's why I had so much trouble. Not only did I have trouble in getting the right series, but then in the radius of it, I got that wrong too, because I had the wrong series, right? So what's the Fn for? I'll write this down now. And you want to clear up your mistakes before it's too late. And this will be x minus 4 to the n. Let me get my eraser out. I went too far with that. And let me write this fn4 down now. What's that going to be? Minus 1 to the n factorial over n plus 1. All right. And now I'm seeing my mistake. So what happens over here? These cancel off. And let me just clean it up a little tiny bit, and then we'll look at our k. Whoops, I don't want to get red ink here. It doesn't look right. Minus 1 to the n, x minus 4 to the n, and n. You know what? I forgot something too. It's 3 to the n there. Sorry about that. I'm really screwing up. And then n plus 1. Okay. So I got this. Made a couple mistakes in that, but I'm getting better. Hopefully I won't make too many more mistakes. And let's do the radius of convergence now. Limit n goes to infinity. That's going to be minus 1 to the n plus 1, x minus 4 to the n plus 1, 3 to the n plus 1, n plus 2. I'm going to be dividing by an or multiplying by its reciprocal, which is 3n, n plus 1. And then you get minus 1 to the n and x minus 4 to the n. And I want that to be less than 1. All right. So let's take a look and see if we can do that. Whoops, I didn't mean to do that. And I'm going to see if I can get this limit going. Well, this again, it's going to be minus 1 to the n, but the absolute value, that's 1. Let's do this now. What does that give me? X minus 4. That's pretty simple. This would give me 1/3 in the bottom. I'll put that down for you. 3 in the bottom, I mean 1/3. And then you're left over with n plus 1 over n plus 2, less than 1. Well, let's come to the absolute value of x minus 4 over 3 times this guy's limit, which is 1, and that's going to be less than 1. So let's put this down. And as I do this, I'm just solving an inequality right now. This will be x minus 4 absolute value less than 3, which means x minus 4 is between 3 and minus 3. I would add 4 to all sides. And what would you get? You get 1. Over here, you get 7. What's the length of the interval? It's 6 units. So what's the radius? The radius will be 3. All right. By the way, they didn't ask for the interval. At least I don't think so. I want to go back over that. And I want to make sure I've read that correctly. Untitled Series and the radius of convergence. The radius of convergence is 3 as we came up with. All right. Okay. What should you realize here? Mistakes are easy to happen. Fess up to it. Get the right thing. All right. Use the binomial series. It gives it to me to expand at least the first 10 terms of the power series. Yikes. Let's see if we can do it. All right, let's see if we can do that. So I got a couple of problems here. And the first problem I have is the way it's written. So this needs to be written as 1 plus minus x to the 2/3. Well, let's write it down. We get a 1 plus, what's k? It's 2/3. What do you get? The x minus x now, right? We'll clean it up later. Plus, let's write this down. What's k? 2/3. And it's going to be 2/3 minus 1 over 2 factorial. I'm just writing things down. Then what do you get over here? Minus x squared plus, I'm on a roll. I'll keep going. 2/3. 2/3 minus 1. 2/3 minus 2 over 3 factorial. What goes there? Minus x cubed. Could I keep doing this? Yes. 2/3. 2/3 minus 1. 2/3 minus 2. 2/3 minus 3. All over 4 factorial. Minus x to the 4. yada, 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 yada. All right. Now, someone could say, how could you do that, on a machine? Well, I got to tell you something. I want to just do it if I can get the first terms going. All right. So I'm going to look at this thing, and I notice that this term over here, let me get my red ink out. This term is that term. That looks pretty good. And this term is this term. That looks pretty good. Now I'm going to verify the next term. And someone says, why do you do that? I want to see if I'm right. That's all I want to say. So the next term is going to be plus x squared. And what do you get over there? Well, 2/3 and then minus 1/3. I'll write this over here. 2/3 minus 1/3, isn't it? Over 2. And what do you get over there? Oh, gee, you get minus 1/9 x squared. I'm seeing it right here. Let's do the next one. See, I'll go with that. So what do you have there? It's tough. I'm not saying it's easy for you. 2/3. 2/3 minus 1 is minus 1/3. I realize what some students are saying. They don't think they need to be able to do arithmetic. You got to be able to do arithmetic. You really be able to read, write, and do arithmetic. It's the 3 skills that you really do need. 2/3. Oh boy, that's going to be tough, right? 2/3 minus 2. That's going to be 6/3, right? That's minus 4/3. You get the idea? What's 3 factorial? It's 6. What's minus x cubed? It's minus x. I'm sorry. I went too quick there. I'll just do it. It's going to be x cubed, but subtract. Let's see if we can do that. So what do I get? I get minus 8, right? On top I get 8. It's a minus 3 times 3 is 27. 27 times 6. What do you get over there? Well, I got to reduce it, right? So 4 and 3. So minus 4 over 81 x cubed. Let's see if we got that right. Yep, I got this one over here. Again, someone's going to say, could you do the next one and next one and next one? Of course I could. All right. The key about this one over here is, how would you plug this into a computer? And that could get really, really nasty, particularly if you don't have much programming skills. All right. But I got a claim over here, kind of looking at it. And maybe I should go through that with you. And maybe I should go through it with you. So let me write this down over here and see why I see a pattern. So, 2/3, and this would be 2/3 minus 3/3. All right, I'm just doing this one over here. What's next one going to be? Well, before I do that, maybe I should just write this down. What's going to be? Well, 2, and I would get minus 1, right? And that would be over 3, which is 3 times 3, which is 9. All right, and that's tough. I'm not saying it's easy. Let's do the next one. Well, it's partially done, isn't it? It's what is going to be, 2/3 minus 3/3. We just did that, right? And then we're doing this one over here. And that's going to be 2/3 minus 6/3. Well, let's write that down. I already did this thing, so I don't want to do that again. So what do you get? 2 times minus 1 over 9. And what would that give me? Well, that's going to give you minus 4/3. All right. So this is this one here. And I just did this one over here. I didn't put the factorial down yet, though. Just doing the top. All right. What do you get over there? Well, this one is just simply minus 1 times 2 over 3 squared. Let me write this one down. This is going to be plus 3 cubed on the bottom now, right? And then what do you get on top? Let's see. You get, it's a positive, isn't it? So it's going to be, let's see, I would say 2 times 4, right? I think you get the idea. All right. So if I keep looking at that, I'm going to keep moving forward. And I'll see if I can do that. And the next one, let me see if I need to move forward on it. Yeah, I think I do. Let me put the next one down. So the next one's going to be 2 times 4 over 3 cubed times the next term, which would be 2/3 minus 3. I got to do it. So it's going to be 2 times 4, 3 cubed. And this is going to be a 3 again. This is 2 minus 9. So what do you get over there? I guess you get minus, don't you? Minus let's see, 3, what would that be? 3 to the 4th, right? Boy, this is a really nice pattern right now. You know, I'm seeing these threes coming in each time. That makes sense, by the way. And what do you get over there? Well, I guess you get 2, 4, 7. All right. So the only thing I'm doing, maybe I should outline what I'm doing here. And I know it's difficult. I'm not saying it's easy for you. I'm just doing these things over here. That's all I'm doing. As I kind of move along, I'm just doing those things. All right. Really simple, by the way. All right. Now, when I say simple, you still might not see the pattern to it. But what I noticed is it really, the bottom's easy for me. The bottom's always is 3 to a power. All right. Now, what's the power going to be? Well, it looks like the exponent. All right. So I want to point out, I kind of see that pattern, 3 to the exponent. For example, remember what I said about this one over here, that I get the, 3 squared, then next one's going to be 3 cubed, so forth and so on. So I think I got that covered. And then the n factorial on the bottom, I think I have that covered too. But this other thing, it's really tough for me. And I want to point out, I'm just looking at that top, but I do recognize, I think I might have made another mistake. Oh, you know what? I didn't account for the minus sign yet. And I got to go through that with you. And yeah, for the odd ones, it's going to be negative. And it's going to be, let's see, that would be, yeah, I forgot to account for that. And that's a problem. I forgot to account for it. And it actually makes it easier, but I'm glad I accounted for that. And I wasn't thinking about this part over here. And the reason for that is I want to point out these guys over here, depending on power, are going to be like even powers will be, positives. And the odd powers will be negatives, which is taking care of that alternating part of this problem. Everything is going to be negative now. And what I'm going to do now is factor out a minus. I'm going to factor out a 2 on that over there. And what would you be left off with? By the way, we've already accounted for the bottoms. We've already done that. What are you going to get over there? 1. What's the next term going to be? Plus, I factor out 2, so it's going to be 1 times 2. And then I factor out a 2, right? I'm sorry, 1 times 4. I'm sorry. Next one's going to be 1 times 4 times 7 plus. All right. So I'm going to say, I think I see a pattern to this one as well. And what's the pattern going to be? 1, 1, 4, 1, 4, 7. What's the next term going to be? It's tough. We're not saying it's easy. 1, 4, 7. And it's going up by what? It looks like it's going up by 3 and then 10. And that makes sense, going up by 3. So that's what they're writing over here. And, 1, 4, 7, 10. What's the pattern going to be for these guys over here? Well, if you look at it, it's going up by 3. So something to do with 3n. But I want to point out over here, I got to get very careful with this guy over here. So let's see. I guess I should put a 1 there. All right. So that's going to be the first guy, right? And that would be 3n. I did the 1 and I go to 2. Well, actually, I'm up to 2 now. And I want it to be, that would be 6, right? If I was starting at 2. Again, we're starting at 2. That's 6. So I need to take away 1. Let me see if I get the next one. So if I go to 2, what would I get? I'm sorry, I meant 5. I meant 5. Because if I start at 2, that would be 6 minus 5, which is 1. If I go to 2, that's 6 minus, oh, I said, did I say 2? Let me see what I said. 2, 6. Oh, yeah. If I'm starting at 2, I'm not going to 1. I'm going to 3. 3 times 3 is 9. 9 minus 5 is 4. Yeah, that's working out. So the tough thing over here, and I want to point out, this is tough. There's no doubt about it. Getting this pattern over here. Anyway, even writing it down doesn't make it any easier. All right, writing it down. So I'm going to say on exams, what I kind of expect from you, can you compute the first, I don't know, maybe 1, 2, 3, 4. But I got to be honest with you, beyond that might be pretty difficult to compute. All right. But if you have a machine, you can expand as much as you want. All right. So let me go to the next page. I know it's tough. And what I did was I graphed it out. And someone says, how could you have graphed that out? I didn't do it by hand. I did it on a machine. And what did I graph on a machine? I want to point out what I graphed on the machine is I graphed this out, which is 1 minus x to the 2/3. I'll write that down for you. And I graphed out, believe it or not, the Taylor polynomial for this. Where'd that come from? The work I just did. And I'll go through that later with you, okay? So let me, next one up. Looks pretty simple to me. I'll tell you why. There are two series that I know about, and I'll write them down for you, all right? So they want me to add these together. I don't like adding things together, but I'll write it down for you. So what's f of x? It's going to be e to the minus x squared plus cosine x. Well, I'm going to write down cosine x first because it's easy. What's that going to be? 1 minus x squared over 2 factorial. And again, I don't enjoy writing this down, by the way, but I can. Plus x4 over 4 factorial minus x6 over 6 factorial. And I think you get the idea that I could write that down for a very long time. And what's the other guy going to be? Well, it's cosine e to the minus x squared. I want to point out, for me to do this, I would like to know what e to the u is, and then I'll just pop it in. What's e to the u? 1 plus u plus u squared over 2 factorial plus u3 over 3 factorial, yada, yada, yada. What do you have here? 1 plus minus x squared plus minus x squared squared over 2 factorial plus minus x squared cubed over 3 factorial. All right. I hope that wasn't too difficult to do. I'm going to erase this now. Don't worry, we'll look at the key later. Now, granted, you could write this down as a sum if you want, but I think they just want me to write down, a few terms. All right. Let me do that though. Let me start writing this down. So if I add this together, let me write it over here. And I'll write f of x down. Oh, let's see. 1 plus 1 is 2. That was easy. Now, what do I know about the next term? I know it has an x squared in it. I'm seeing it right over here. All right, but I got to write this down now. So it's a minus though, isn't it? So let me get my eraser out. I know it's tough, but I have to do it. I mean, I really do. I have to do it. And what do you get? 1 over 2 factorial plus 1 over 1 factorial. And we do the next one. Plus 1 over 4 factorial plus 1 over 2 factorial x4. All right, let me do the next one. It's going to be minus though, right? And I think I'm on a roll now. So it's going to be 1 over 6 factorial plus 1 over 3 factorial x6. All right, I don't know if I want to do the arithmetic over there because I think I'm ready to write down a sum. 2 plus minus 1. It's alternating, right? Plus, minus, plus, minus. Well, let's do this factorial business first. And there's going to be x. I'm going to say 2n. So n starts at 1. So that would give me the x squared 4, 6. That looks like it's okay. And if I start at 1, yep, that's okay. Put an n here. And I got to do that factorial business, don't I? And it's 1 and 1. We'll look at the key later. What do you get there? Let's see, 2. Wow, that's pretty simple. That's just 2n. And what's the other one going to be? 1, 2. It's just n. So it's 2n factorial and n factorial. All right, so I got my series expansion for it. Let's check it, see if we did okay. And I want to see if they wrote that down, by the way. They did the computations. I'm not too interested. I'm a little tired doing computations. Let's see if we got the right term. Yeah, we did. It's right over here. They're giving it to us, which is good news. All right. Let me go to the next page. They want us to graph this. Over here, I do want to point out graphing these guys does require the use of machine, including this one over here. It's just too difficult to graph by hand, but I do it for you. And I talk about how to do that. I'll go to Sage later, by the way. All right, let me do this one over here. I want to see if I can understand what they're asking me to do. And it says differentiate that for the Maclaurin series. Before I do that, though, I want to point out that I kind of know what the Maclaurin series is because I know something. What do I know? I know 1 over 1 minus u is equal to 1 plus u squared. But what do they give me? They're giving me 1 minus 6x. So what's that going to be? 1 plus 6x plus 6 squared x squared plus 6 cubed x cubed plus yada, yada, yada. All right. So what do they want me to do? It's tough. They want me to, what do they want me to do? Differentiate that twice. Oh, they're killing me. Let me put this down. I'm going to differentiate twice. So what am I differentiating? This is really 1 minus 6x to the minus 1 equals 1 plus 6x plus 6 squared x squared plus 6 cubed x cubed plus yada, yada, yada. Well, let's differentiate twice. I have no idea what's going to happen. Minus 1 minus 6x to the minus 2 times minus 6. All right, that's not so bad. That's one differentiation. What do we get over here? 6 plus 6 squared times 2x plus 6 cubed times 3x squared plus, I think you get the idea. Let's differentiate again. That's going to be tough. 2, 1 minus 6x minus 3 minus 6 squared. All right, let's write this down now. 6 squared times 2 plus 6 cubed times 3 times 2 times x. Let me continue to write these down though, because I think this is really we want to go with the problem. So 6 squared, 6 cubed, I guess I get 6, 4, right? Then what would you expect to get? Well, let's take a look at that. And I'm going to be really careful about this. I'm going to say, what would you get? Well, I'm going to be real careful about this because what's the next term going to be on? So if I did that, that would be 6, 4, x4. So what do I get over there? Well, I get the 6, 4, certainly. But then I'd get 4 times 3 x squared. So I'm starting to see patterns in this, all right? At least I hope you're seeing a pattern too. And before I do that, I want to clean it up a little tiny bit. And what do you get over there? Well, you get 36 times 2, which is 72, right? Times 1 over 1 minus 6 x to the third power is equal to 6 squared times 2. You can write that as 2 times 1 now. Plus 6 cubed, 3 times 2x, plus 6, 4 times 4 times 3 x squared. I could do this all day long, I think. 6, 5 times 4 x cubed, yada, yada, yada. I think I got that pattern down. Now, what I'd like to do is I would like to divide both sides by 6 squared now. All right, let me put that down for you. So what would I get? I would get 2, 1 minus 6x cubed, and I'm dividing by 6 squared. What do I get? Well, I would get 6 to the 0, 2 times 1, plus 6 to the 1, 3 times 2, plus 6 squared, 4 times 3, x squared. That would be 6 cubed now, right? 5 times 4, x cubed. And I think yada, 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 some in order there. So what do they want me to do? And you say I lose track of things. I don't know what they want me to do. They want to find a Maclaurin series. And I think I've got it per chance for this. What is it going to be? 1 over 1 minus 6x cubed is going to be 1/2 this series over here. Let's write it down. So it's going to be 6 to the n. N starts at 0 and goes to infinity. And then I'm going to put the x down. It's going to be x to the n. None, 1, 2. Yep, that seems to work. And now I got to put that product down. And that looks like a crazy little product over there. But what's it going to be? Well, it looks like n plus 1. I want to put what I'm saying over here. If n is 0, you get 1, and then you get 2, and then you get 3, and then you get 4. And what's the next guy over there? It's just one more than that number. So it's going to be n plus 2. All right, I think I'm done. All right, it was tough though. I'm not saying it wasn't tough. By the way, when I look at their answer, you may be shocked their answer is not exactly like mine. I'm not saying I didn't make an error, but let's take a look. I'm going to box it. Made a lot of work though. And again, the reason we're doing this, we're trying to teach how to do homework. All right, even though it's not homework, this is the way I would be doing homework. I would be looking carefully at their answers, maybe not their work, by the way, but carefully at their answers to see if I got the same answer. I got the sum. And I noticed they did some things that I'm not going to say are silly, but they took this and turned into that. I see the n plus 2. I see the n plus 1, and they brought the 2 on the inside. So yes, I got the same answer. All right. Now, by the way, I got to go back and make sure I read the question. Yeah, we did that. All right. We got everything covered. All right. This one over here says express the integrals in infinite series. I think I can do that. And let's go through it one step at a time. Assume is all fine at 0. In other words, don't worry about writing down an improper integral for it. Okay. So the first thing I want to do is I want to do the top, which is 1 minus the cosine of t. And then we'll divide through by t. There's going to be 1 minus, well, what's a cosine? It's going to be 1 minus t squared over 2 factorial plus t4 over 4 factorial minus t6 over 6 factorial, yada, yada, yada. I think you get the idea. Now, if you do that, what do you get? Well, you get t squared over 2 factorial minus t4 over 4 factorial plus t6 over 6 factorial. Yada, 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 yada. What are we going to do? Divide that by t. What does that give me? T over 2 factorial minus t cubed over 4 factorial plus t5 over 6 factorial minus yada, 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 yada. All right, I think you get the idea. So what do I got to do over here? I got to do an integration now. And let's write that down. So what am I doing? I'm doing 0 up to x. It's going to be t over 2 factorial minus t cubed over 4 factorial plus t5 over 6 factorial. And I'm going to say minus yada, yada, yada. That's a dt. Can I do that integration? I think so. So what are you going to get? T squared 2 times 2 factorial minus t4 over 4 times 4 factorial plus t6 over 6 times 6 factorial minus yada, yada, yada. I'm saying it's a predictable pattern right now. What's the integration? 0 to x. So I can write that down, and you're going to get x squared 2 times 2 factorial minus x4, 4 times 4 factorial plus x6, 6 times 6 factorial, yada, yada, yada. Minus, well, the lower limit couldn't be easier. Every term will be 0. So what do I have now? I have my series now, and I'll write down for you. And that's going to be x. I'm going to start n at, let's put 2n here, 1, and we're going to go off to infinity. All right, I know it's alternating. I'll put a -1 over here, and I'm going to put n plus 1 here. All right, so I think it covers the alternating and the powers. But again, in bottom, 2n times 2n factorial, and I think I'm done. Now, Grant, when I say I think I'm done, I make mistakes sometimes. Let's take a look at it, see how we did. And again, we're trying to encourage this. And someone says, what are you trying to encourage? Looking, examining, being critical of what you're doing, including if you make a mistake, know you made a mistake, try to correct it. And let's see what we got over here. See if we got the right answer. And I'll get my red pen out. And I got the sum, -1 to the n plus 1, x to the 2n, 2n, 2n factorial. It looks great. Now, granted, you're going to make tons of mistakes. You want to make those mistakes before you get to an exam. I can't say it enough times to you. Exam's not the place to be making mistakes. You do this before you get the exam. I do want to encourage you that Essex County College, typically our exams are going to look exactly like what we're presenting to you in class, exactly like it. There's not going to be much variation from it. All right. As you move forward, though, standardized tests, they don't look like what you've seen before. They're testing your ability to synthesize information. All right. So to get new and novel problems to see how you address that. Some of you guys are going to end up in interviews at companies where you're going to ask you questions. And by the way, they spend a lot of time and effort in coming up with novel questions that people have not seen before. All right. And by the way, if you've seen the question before, that would be considered cheating. All right. So here's the deal. On our exams, the best way to cheat is to do your homework and make sure you know what that means. So let me just go to the next page, point that out to you. What's the next thing up? Do the homework. Someone says, I don't need to do that. I watched you enough. No, you haven't tried yourself. You need to start trying this. All right. Thank you so much. And if you need help, please come by and I'll try to give you help.